The Lockheed Martin/Boeing F-22 Raptor is an American single-seat, twin-engine, supersonic all-weather stealth fighter aircraft developed for the United States Air Force, USAF. As a product of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed as an air superiority fighter, but also incorporates ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while program partner Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft first flew in 1997 and was variously designated F-22 and F/A-22 before it formally entered service in December 2005 as the F-22A. Although the USAF had originally planned to buy a total of 750 ATFs, the program was cut to 187 production aircraft in 2009 due to high costs, a lack of air-to-air missions at the time of production, and the development of the more affordable and versatile F-35. The last F-22 was delivered in 2012. While it had a protracted development and initial operational difficulties, the F-22 has become a critical component of the USAF's tactical air power. The fighter's combination of stealth, aerodynamic performance, and mission systems enabled a leap in air combat capabilities and set the benchmark for its generation. Armament. The F-22 has 3 internal weapons bays, a large main bay on the bottom of the fuselage, and 2 smaller bays on the sides of the fuselage, aft of the engine inlets. A small bay for countermeasures such as flares is located behind each side bay. The main bay is split along the centerline and can accommodate 6 LAU-142/A launchers for beyond visual range (BVR) missiles, and each side bay has an LAU-141/A launcher for short-range missiles. The primary air-to-air missiles are the AIM-120 AMRAAM and the AIM-9 Sidewinder, with planned integration of the AIM-260 JTM. Missile launches require the bay doors to be open for less than a second, during which pneumatic or hydraulic arms push missiles clear of the aircraft. This is to reduce vulnerability to detection and to deploy missiles during high-speed flight. An internally mounted M61A2 Vulcan 20mm rotary cannon is embedded in the airplane's right wing root with the muzzle covered by a retractable door. The radar projection of the cannon fire's path is displayed on the pilot's head-up display. Although designed for air-to-air missiles, the main bay can replace 4 launchers with 2 bomb racks that can each carry 1,000 pounds, 450 kilograms, or 4 250 pounds, 110 kilograms, bombs for a total of 2,000 pounds, 910 kilograms, of air-to-surface ordnance. While capable of carrying weapons with GPS guidance such as DAMs and SDBs, the F-22 cannot self-designate laser-guided weapons. While the F-22 typically carries weapons internally, the wings include 4 hardpoints, each rated to handle 5,000 pounds, 2,300 kilograms. Each hardpoint can accommodate a pylon that can carry a detachable 600-gallon, 2,270 L, external fuel tank, or a launcher holding 2 air-to-air missiles. The 2 inboard hardpoints are plumbed for external fuel tanks. The 2 outboard hardpoints have since been dedicated to a pair of stealthy pods housing the IRSD and mission systems. The aircraft can jettison external tanks and their pylon attachments to restore its low observable characteristics and kinematic performance. Produksi Dan Pengadon. The USAF originally envisioned ordering 750 ATFs at a total program cost of $44.3 billion and procurement cost of $26.2 billion in FY $1,985, with production beginning in 1994 and service entry in the late 1990s. The 1990 Major Aircraft Review led by Secretary of Defense Dick Cheney reduced this to 648 aircraft beginning in 1996 and in service in the early to mid-2000s. After the end of the Cold War, This was further curtailed to 442 in the 1993 bottom-up review, while the USAF eventually set its requirement to 381 to adequately support its Air Expeditionary Force structure with last delivery in 2013. However, funding instability had reduced the total to 339 by 1997, and production was nearly halted by Congress in 1999. Although production funds were eventually restored, the planned number continued to decline due to delays and cost overruns during EMD, slipping to 277 by 2003. In 2004, with its focus on asymmetric counterinsurgency warfare in Iraq and Afghanistan, the DoD Undersecretary Donald Rumsfeld further cut the planned F-22 procurement to 183 production aircraft, despite the USAF's requirement for 381. A multi-year procurement contract was awarded in 2006 to bring the number to 183, which would be distributed to 7 combat squadrons. Total program cost was projected to be $62 billion, $81.4 billion in 2021. In 2008, Congress passed a defense spending bill that raised the total orders for production aircraft to 187. F-22 production would support over 1,000 subcontractors and suppliers from 46 states and up to 95,000 jobs, and span 15 years at a peak rate of roughly 2 airplanes per month, about half of the initially planned rate. After EMD aircraft contracts, the first production lot was awarded in September 2000. As production wound down in 2011, the total program cost was estimated to be about $67.3 billion, about $360 million for each production aircraft delivered, with $32.4 billion spent on research, development, test and evaluation, RDT, and $34.9 billion on procurement and military construction. Milken in then-year dollars. The incremental cost for an additional F-22 was estimated at $138 million, $172 million in 2021, in 2009. In total, 195 F-22s were built. The first 2 were EMD aircraft in the Block 1.0 configuration for initial flight testing and envelope expansion, while the third was a Block 2.0 aircraft built to represent the internal structure of production airframes and enabled it to test full flight loads. 6 more EMD aircraft were built in the Block 10 configuration for development and upgrade testing, with the last 2 considered essentially production-quality jets. Production for operational squadrons consisted of 74 Block 10 20th training aircraft and 112 Block 30 35th combat aircraft for a total of 186, or 187 when accounting for production representative test vehicles. One of the Block 30 aircraft is dedicated to flight sciences at Edwards Air Force Base, California. Block 20 aircraft from Lot 3 onward were upgraded to Block 30 standards under the Common Configuration Plan, increasing the Block 30-35 fleet to 149 aircraft while 37 remain in the Block 20 configuration. Larangan export. The F-22 cannot be exported under U.S. federal law to protect its stealth technology and classified features. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on the U.S. aerospace industry. Some Australian politicians and defense commentators proposed that Australia should attempt to purchase F-22s instead of the planned F-35s. Citing the F-22's known capabilities and F-35's delays and developmental uncertainties, the Royal Australian Air Force (RAF) soon determined that the F-22 was unable to perform the F-35 strike and close air support roles. The Japanese government also showed interest in the F-22 for its replacement fighter program. The Japan Air Self-Defense Force, JSDF, would reportedly require fewer fighters for its mission if it obtained the F-22, thus reducing engineering and staffing costs. In 2009, it was reported that acquiring the F-22 would require increases to the Japanese government's defense budget beyond the historical 1% of its GDP. With the end of F-22 production, Japan chose the F-35 in December 2011. Israel also expressed interest, but eventually chose the F-35 because of the F-22's price and unavailability. Stealth. The F-22 was designed to be highly difficult to detect and track by radar, with radio waves reflected, scattered, or diffracted away from the emitter source towards specific sectors, or absorbed and attenuated. Measures to reduce RCS include airframe shaping such as alignment of edges and continuous curvature of surfaces, internal carriage of weapons, fixed geometry serpentine inlets and curved vanes that prevent line of sight of the engine faces and turbines from any exterior view, use of radar-absorbent material, RAM, and attention to details such as hinges and pilot helmets that could provide a radar return. The F-22 was also designed to have decreased radio frequency emissions, infrared signature and acoustic signature, as well as reduced visibility to the naked eye. The aircraft's flat thrust vectoring nozzles reduce infrared emissions of the exhaust plume to mitigate the threat of infrared homing, heat-seeking, surface-to-air or air-to-air missiles. Additional measures to reduce the infrared signature include special topcoat and active cooling to manage the heat buildup from supersonic flight. Compared to previous stealth designs like the F-117, the F-22 is less reliant on RAM, which are maintenance-intensive and susceptible to adverse weather conditions. Unlike the B-2, which requires climate-controlled hangars, the F-22 can undergo repairs on the flight line or in a normal hangar. The F-22 incorporates a signature assessment system which delivers warnings when the radar signature is degraded and necessitates repair. While the F-22's exact RCS is classified, in 2009 Lockheed Martin released information indicating that from certain angles the airplane has an RCS of 0.0001 square meters or minus 40 dBsm, equivalent to the radar reflection of a steel marble. The aircraft can mount a Lunabig lens reflector to mask its RCS. Effectively maintaining the stealth features can decrease the F-22's mission-capable rate to 62 to 70%. The effectiveness of the stealth characteristics is difficult to gauge. The RCS value is a restrictive measurement of the aircraft's frontal or side area from the perspective of a static radar. When an aircraft maneuvers, it exposes a completely different set of angles and surface area, potentially increasing radar observability. Furthermore, the F-22's stealth contouring and radar-absorbent materials are chiefly effective against high-frequency radars, usually found on other aircraft. The effects of Rayleigh scattering and resonance mean that low-frequency radars such as weather radars and early warning radars are more likely to detect the F-22 due to its physical size. These are also conspicuous, susceptible to clutter, and have low precision. Additionally, while faint or fleeting radar contacts make defenders aware that a stealth aircraft is present, reliably vectoring interception to attack the aircraft is much more challenging. According to the USAF, an F-22 surprised an Iranian F-4 Phantom II that was attempting to intercept an American UAV, despite Iran's assertion of having military VHF radar coverage over the Persian Gulf. Beginning in 2021, the F-22 has been seen testing a new chrome-like surface coating. This highly polished surface appears to change color based on the viewer's orientation to the aircraft. It is speculated that the new coating will help to reduce the F-22's detectability by IRSD and other infrared tracking systems and missiles. This coating has also been seen on some F-35 and F-117 test aircraft.